Next topic is Arrhenius concept. According to Arrhenius concepts, acids are those substances which gives hydrogen ion when dissolved in water. So acids gives hydrogen ion when dissolved in water. For example, Ha is an acid. When it is dissolved in water, it produces hydrogen ion and negatively charged ion. Similarly, examples of acids according to Arrhenius concepts are HCl. When it is dissolved in water, it produces hydrogen ion and negatively charged chloride ion. Here HCl is an acid because it dissociated into hydrogen ion when dissolved in water. Similarly, H2SO4 also dissociated into H positive and HSO4 negative ions when dissolved in water. Here this HSO4 negative ion still has one hydrogen ion, so it can also donate one hydrogen ion in aqueous medium, so that's why it also dissociated into H positive and SO4 minus 2 ions. So H2SO4 is dissociated into 2 hydrogen ion and sulfate ion in 2 steps. Similarly, other example is H3PO4 phosphoric acid. When it is dissolved in water, it produces hydrogen ion and phosphate ion. So it produces 3 hydrogen ion here. Similarly, acetic acid CH3COOH, when it is dissolved in water, it produces hydrogen ion and acetate ion. Similarly, according to Arrhenius concept, bases are those substances which produces hydroxide ion when dissolved in water. For example, BOH, it is base, it produces hydroxide ion when dissolved in water. For example, NaOH, when dissolved in water, it produces Na positive and OH negative ion. So NaOH is base. When it is dissolved in water, it produces hydroxide ion. So according to Arrhenius concept, NaOH is base. Similarly, calcium hydroxide is also base because when it is dissolved in water, it produces calcium ion and hydroxide ion. So it produces hydroxide ion, so that's why it is base. Similarly, aluminium hydroxide also produces hydroxide ion when dissolved in water. It produces aluminium ion and 3 hydroxide ion. Similarly, NH4OH ammonium hydroxide, when it is dissolved in water, it also produces ammonium ion plus OH negative ions, hydroxide ion. So it is also base. So those substances, according to Arrhenius concept, those substances which produces hydrogen ion when dissolved in water known as acids, and those substances which produces hydroxide ion when dissolved in water are known as bases. Limitations of Arrhenius concept. Arrhenius concepts is limited to the aqueous medium only. It does not explain the acidity or basicity of substances in non-aqueous medium. Of substances in non-aqueous medium. So it is limited to aqueous medium only, as we have studied these acids and bases. They produces hydrogen ion and hydroxide ion when they dissolve in water. Here water is known as aqueous medium. So this Arrhenius concept does not explain the acidity or basicity of substances in non-aqueous medium. According to Arrhenius concepts, acids are limited to the hydrogen ion and bases are limited to the hydroxide ion. So because here acids are those substances which produces hydrogen ion and bases are those substances which produces hydroxide ion, so here Arrhenius concept is limited to hydrogen ion, acids to the hydrogen, limited to the hydrogen ion, and bases are limited to the hydroxide ion only. So other species such as CO2, it is also acidic in nature, but it does not contain any hydrogen ion, but still it is acidic in nature. So here Arrhenius concept does not explain the acidic behavior or acidic nature of CO2. Similarly, bases such as NH3, it is base, but here it does not have any hydroxide ion. So Arrhenius concepts, according to Arrhenius concept, bases are those species which produces hydroxide ion. So here NH3 does not has hydroxide ion, but still it is basic in nature. So here there are two drawbacks or two limitations of this Arrhenius concept. Number one, it is limited to aqueous medium only, and it does not explain the acidity or basicity of the substances in non-aqueous medium. And number two, it is here according to Arrhenius concepts, acids are limited to hydrogen ion only and bases are limited to the hydroxide ion only. And those species such as carbon dioxide, it is acidic in nature, but it does not has any hydrogen ion. So here Arrhenius concept does not explain the acidic behavior of carbon dioxide or basic behavior of ammonia here.